Well, I'm excited to be here because I get to talk about the web. And it's a great time to be talking about the web because, I don't know if you heard, earlier this year we actually celebrated a big anniversary for the web.
That's right. The web's 10 years old now. Because Tim Berners-Lee shared his vision for the World Wide Web in a March 1989 paper titled Information Management, a Proposal, which his boss at the time heralded as vague but exciting. And he worked on this idea at CERN for the next few years, and in 1993, we all got to play along with the release of the free Mosaic browser. And it's been a wild ride since then. The years since, we've seen a ton of websites, new experiences and ideas, and even companies built around the web, many of which I'm sure you've heard of. Maybe some of you even work for one. And the market couldn't love us more. So today what we want to do is share some highlights of the new technologies that have made all of this possible, where we are now, here in 1999, and a glimpse into the future of the web. But first, let's start with the basics. What is the web and how does it work? A web page is just a normal file. It's a rich text document written in HTML that contains clickable hyperlinks that refer to other web pages. And these references come in the form of a URL that has two important parts. The first part is the website, and the second part is the web page. And so with a little bit of magic, your browser finds the actual physical computer connected to the internet for that website, and then asks it for the requested web page. And that computer runs a piece of software called a web server, which translates the requested web page into an actual file stored on its file system. It opens that file up and sends it across the internet back to your browser using a protocol called HTTP, and this is amazing. But over the last few years, we've seen an evolution from serving static files or websites to dynamic programs or web applications. And this lets us make totally new kinds of experiences where the program is being run on the web server, not on your computer. And this evolution started with CGI. And CGI is both dead simple and super clever. CGI extends what a web server can do beyond just reading files by saying, if the requested file is in a certain directory, and we usually use CGI bin by convention, then that file is a program. And rather than just opening the file, it executes it with a handful of environmental variables set from the HTTP request, and then it sends that program's standard out back to your browser over HTTP. And this is so cool because literally any program can now be a web application. It can be anything from a simple shell script to a complex compiled C++ program. Of course, doing anything other than simple tasks is pretty annoying in a shell script, and C++ takes years to master and about as long to compile. So scripting languages like Perl are a pretty good compromise, and they've been pretty popular for CGI. But Perl wasn't really designed with the web in mind. And here, PHP has really taken off. So PHP was written a couple of years ago, back in 1995, but I think it really got interesting to us as a web community last year with the release of PHP 3. It's an open source programming language, and currently the best way to get started on the web. Yeah, I say programming language because its creator said that he never really intended it to be a programming language, but it's definitely Turing complete. It's become popular since it's really the first language built for the web. Its original goal was to process web forms and generate web pages, and it does both of those things really well. But it kind of feels revolutionary to me because it's blurred this line between files as web pages and programs as web applications. For instance, any HTML file is actually a valid PHP program. This one doesn't do anything interesting yet. It's more web page than web program at the moment. But we can insert a PHP tag, and now we're in application land. So for example, we can access some state from a submitted form or a cookie, use that to query our database, and then go right back to HTML, but with fresh data interleaved. And so part of why I like PHP is that it's super easy to learn once you know HTML. You can incrementally include dynamic logic into your existing HTML files, and it scales up to everything that you could do with Perl. And it's free and open source. And I've heard it referred to recently as the LAMP stack. And what that stands for is Linux, the free and open source operating system, Apache, which is a free and open source web server that supports CGI, MySQL is a brand new free and open source database, and then, of course, PHP. So these are all the tools that you need to build and serve web applications. And if you're not familiar with open source software yet, this might not sound like a big deal. But it means that PHP and the rest of the LAMP stack is constantly improving from the web community's contributions, and anyone can use it without payment or licensing concerns. In fact, I predict that this is so important that the recent excitement around the web will inspire a future generation to learn to program, and PHP and the LAMP stack will make it easy to do so. And so all of this makes me wonder, what is the web going to look like in 10 or even 20 years from now? All right, before I get too much further, I guess I should introduce myself. I'm that guy from The Thing. Can we get another round of applause for that? Like, that was amazing, amazing documentary. My name is Byron. I lead web engineering at Robinhood, where we're democratizing access to our financial system. And so I guess you all know by now, I'm one of the creators of GraphQL. I was also an early contributor to React, and I'm responsible for a bunch of other open source projects like Immutable.js and many others. I love open source. And I'm not actually a time traveler, just occasionally detached from reality. I'm fully aware that it's 2019. And that actually means that we recently celebrated the proposal for the web's 30th anniversary, which means that our open source web developer community is well over 20 years old. And it's pretty fun for me to look back on 1999 because that's when I first got involved in the web by teaching myself to program using PHP and, building Pokemon fan sites with the LAMP stack. And in the decade after 1999, the web, and really PHP, exploded in popularity and relevance. The fact that it was free to use, easy to learn, and scalable led to a new post-bubble wave of companies built with LAMP, including some current giants, Wikipedia in 2001, WordPress in 2003, and Facebook in 2004. While PHP gets a lot of well-deserved criticism, it's still pretty relevant and probably way more popular than you think. Today, over 80% of websites are powered by PHP. In fact, 30% of the web alone is specifically powered by WordPress. I had to double check this. This is true. It's crazy. And I spent most of the last 10 of the web's 30-year history working at Facebook, where I saw the evolution of PHP, LAMP, and complex web apps. And what's been most fascinating to me is that now, 20 years later, the programming model and mental model of the web feels largely the same as it did back when these tools were first introduced. Of course, since then, we've tackled growing complexity, have built far richer experiences, we've grown our community 1,000-fold, and we've scaled to reach billions of people on the web. And I see a pattern behind this progress, a relationship between three kinds of advancements: better and more powerful abstractions, clearer and more expressive syntax, and an improved and refined mental models. In fact, these three influence each other in a sort of loop. We build better libraries and abstractions, which unlocks new capabilities and better performance. We introduce new programming patterns, APIs, and ultimately new syntax into our languages to better express ourselves in terms of these abstractions. And that creates clarity, which lets us improve our mental models, how we think about what we build. So I want to illustrate this process through a handful of stories and specific examples that I saw unfold at Facebook across three problems that we've all become really familiar with: rendering views, fetching data, and managing state. And I want to start with rendering views because it's so much of what we focused on as front-end engineers, and it was also PHP's killer feature. PHP really meshed well with this mental model of a web app being a mix of dynamic content interwoven with static content written in the lingua franca of the web, HTML. So PHP kicked off this era of the template language, and more followed: embedded Ruby or ERB in 2004, mustache templates in 2009, and plenty more. These made it really easy to start with static content and then introduce dynamic values over time. But as you needed to start to build anything complex, you quickly realized the need for full Turing-complete logic, which means that these simple template languages either evolved into their own weird programming languages like PHP, or remained crippled and limited in use like Mustache. And even templates with rich logic remain difficult or awkward to modularize and reuse without relying on global variables or really just losing most of the benefits of the template syntax. And then there's security. Templates leave this up to you. Naive, simple-looking PHP code almost definitely suffers from critical SQL injection, cross-site security attacks. These, in particular, were constant thorns in the side of early Facebook. So to resolve these issues, Facebook built a framework called UI Component. It's funny how this has become like a general term now, but UI Component was heavily inspired by MVC frameworks at the time, and also by the browser's DOM API. So for example, a button might be called UI Button Component, which would be a subclass of UI Component, and in order to use this, you would instantiate this class with new, and then you could configure it with a chain of method calls, add children UI components and client-side behavior with a DOM-ish looking API, and then call render to get the complete resulting HTML that you could then send to a browser. This solved all of our problems with templates, so now building a UI was just code. No need to invent a new Turing-complete language, and we have an API designed for modularity and reuse. And importantly, what we're building here is a tree of UI component instances rather than a stream of concatenated strings, which means that it's easier to systemically solve security issues by default. We can automatically escape content correctly based on exactly where it appears in the document. We can always correctly include CSRF tokens in the forms, even if you don't know what that means. Basically, security issues solved. Reuse also led to a standard component library, which improved our product design consistency. And this all sounds great, but a huge downside was that every time we refactored a bit of code from templates to UI components, we just couldn't shake this feeling that the new code was just worse. It was verbose and kind of hard to read, and there's definitely a reason why people prefer to write HTML over directly using DOM APIs. So meanwhile, there's actually the Skunkworks project underway at Facebook to rewrite the site from scratch in an effort to get better performance and shed some of our technical debt. And this, of course, didn't work at all, but it yielded a ton of super interesting technology, one of which was an extension to PHP called XHP. So XHP introduced an XML-like syntax into PHP, inspired by the ill-fated E4X JavaScript project. But unlike E4X, XHP didn't try to add any new runtime behavior or anything that was designed to work with XML. XHP was just syntax sugar atop instantiating typical regular PHP classes. And this made it way easier to describe a tree structure of class instances because it was just as easy to read as HTML. And this was a perfect match for UI components. The implementation details remained basically the same, but the syntax returned to what we loved about templates. But now we had a bunch of added benefits, like we could catch errors like missing closing tags or typos as syntax errors at development time rather than broken views or invalid HTML at production. Do you remember these validator apps that you used to go to and punch in your website and it would tell you all the HTML invalid errors that you had? I haven't used one of those in years. So the better abstraction of UI components with the better syntax of XHP further clarified our mental model of building modular UI by defining them in terms of other modular UI. And that allowed us to replace an imperative mutable DOM-style API with a more declarative functional API. So you may or may not have heard of XHP before, but even if you haven't, you're probably seeing all this and thinking, JSX. And so you might not know this, but the initial versions of React did not include JSX. The author of React, Jordan Walk, had been working on the ideas behind React before he joined Facebook, and the idea to change the syntax of the language along with a library of code was not something on his mind at the time. But as other front-end engineers at Facebook first started to see React, they immediately responded with skepticism. Their mental models had already been shifted by XHP, and it wasn't until introducing JSX that React started to get adoption across Facebook. So imagine our surprise when we open-sourced React in 2013, and people hated it. Specifically, they hated JSX. People were mean. Facebook engineers had already adjusted their way of thinking about developing UIs thanks to XHP, but it would take another couple of years for the rest of the web community to come around to the ideas in JSX. And I think this refinement of abstractions, syntax, and mental model continues with post-React UI libraries like Vue.js or Svelte. They take it full circle back to this original compelling idea that any bit of HTML is also valid code. And this feels familiar in a way, like the simple PHP code from 1999, where any HTML was just valid PHP. So looking back, part of what I think made LAMP so empowering was just how easy it was to set up and use a MySQL database and create data-driven views. Early simple web apps had this easy-to-follow imperative code where you query your database with SQL, save the result to a variable, and then render a template with that variable. And this worked great in the era where a web app was just a single machine with an instance of PHP and MySQL. And it was simple, worked well, it was pretty easy to maintain. But it couldn't really scale past thousands of users or to large teams of developers or to do complex data-rich apps. Of course, Facebook needed to do all of these things, especially as they started to work on stuff like Newsfeed. And Newsfeed made data fetching really challenging because there weren't really performant SQL queries that you could write that would get everything that you needed for a feed of very different kinds of stories. And even if there was, Facebook was using memcache to improve performance, and that required cacheable key value pairs. And so building Newsfeed with memcache led to this dreaded N+1 problem that we've heard about over the last couple of days, attempting to load multiple values from a list of keys, each independently, and that leads to all these simultaneous blocking queries, which basically makes stuff super slow. So Facebook solved this by building a library called Preparable, which you got to hear a bit about from Dan in his talk yesterday morning. But I just want to quickly recap kind of what these things were about. A preparable was just a simple state machine. It was a class instance with a method called prepare that had a switch statement in it. And it was passed a number for what state it was in. So each step either enqueued some data that needed to be fetched and returned true, which meant that it should advance to the next state, or it fetched some additional data and returned false that said that that was the last step and it was done. So a preparer would then collect a list of all the relevant preparables, each focused on a specific need, newsfeed, notifications, whatever, and call prepare on all of them. When all preparables were stuck waiting, a single batched request would get sent out to memcache, like Dan was mentioning yesterday, for everything requested up to that point. Then it can return and advance the state of all the preparables, and it can just continue like this in a loop until everything is completed. So this solved our N+1 problem because it resulted in the fewest batches of memcache requests, regardless of how complicated the web page was. And it also allowed for every element of the page to have independent modular logic. So this let us grow to have a complex, data-rich app while maintaining both good performance and modular maintainable code bases. So preparables worked pretty well, but as you might suspect just from looking at that simple code example, they were a source of bugs. It was pretty easy to accidentally forget a return or a break statement in your switch case, maybe forget to renumber things when you refactor. Lots of pitfalls here, but we stuck with it. We did our best in code review, write linters, that kind of thing. And I thought this was like super clever until I learned about generator functions. Generators are functions that, rather than running completely from top to bottom, like regular functions do, they actually let you yield control back to whoever called you as many times as you want. And then the caller is responsible for asking it to carry on with its execution by calling a next method. So generators have been around for a while in some form since the 70s, but were recently popularized by Python in 2001, and then introduced to JavaScript by Mozilla in 2006 as a proposed addition to ES4. So ES4 was then canceled after years of work. And then this project called Harmony was started that was going to bring back some of the features of ES4, and then that took forever, and that effort was later named ES6, and then that also took forever. So generator functions actually went 10 years from Mozilla's first version to actually being standardized and shipping in browsers everywhere. So perhaps unsurprisingly, JavaScript developers at the time were pretty apathetic. They had no confidence that Harmony would ever ship in browsers, so they took it upon themselves to build tools that allowed them to extend the language before browser support would be available. You probably all have heard of or maybe use one of these, Babel. Before it was called Babel, it was called 6 to 5 because it literally translated ES6 to ES5. But even before that project, one of these very first translators was called Regenerator. And this specifically transformed generator functions into JavaScript that any browser could run. And this blew my mind. Because I thought generators were this new runtime concept thing, and so doing this shouldn't be possible. So I had to learn how it worked. So I wrote a simple generator function, put it through Regenerator, and what came out the other side was a preparable. So I learned that a generator function is syntax sugar for preparables. It's a way to describe a state machine, and they can just get translated into this terrible bug-ridden code that we were writing ourselves manually. And so, of course, later enhancements to the preparable framework at Facebook included things like nested child preparables, handling errors, adding loops and complex state transitions. And all of these align directly with generator function syntax, like yield star and try catch, and just regular control flow, like for and while loops. Generator functions, they give us syntax for state machines, but preparables are really more than just a state machine. Preparables are really about complex asynchronous behavior that results in a single final state. And that actually is much better aligned to a different ES6 feature called promises. So you can really think about preparables as a chain of then callbacks of promises. This works actually really well with how Facebook thought about preparables. And so in 2012, we spotted an even better fit. C# had introduced this idea called async functions, which was this unholy union between the state machine modeling world of generator functions and then this asynchronous abstraction of promises, or C# called them tasks. So light bulbs went off, and the Facebook team again extended the PHP syntax to include async and await, and we undertook this huge effort to replace preparables with easier to understand and far less error-prone async functions using basically the techniques that we heard from QA earlier. As Dan mentioned yesterday, these syntax improvements continue to this day. This is still very much a domain that we should care about. And this kind of thing further clarified our mental model, and later async functions and XHP merged together to create GenXHP, where data fetching and component rendering could become co-located in one function. And that led to much better encapsulation of complex data-driven components. And all of this was happening right when we were starting work on GraphQL. So I think you can actually see the influence of all of this historical work, async functions, preparables, on both the syntax and the execution behavior of GraphQL queries. In fact, we later realized just how important preparables were to how GraphQL worked, that we were inspired to create an open source data loader to help solve this exact same n+1 problem for JavaScript. And the resulting mental model from using GenXHP inspired front-end engineers at Facebook to build Relay, which borrowed this exact same idea of co-locating data needs with UI components from the server to the client. So this evolution of better abstractions, clear syntax, and refined mental models led to these ideas like GenXHP and Relay that actually feel pretty familiar. It feels like that PHP code from 1999, where you just asked for what you wanted, got it in a variable, and then rendered what you needed on the screen. So early web apps actually used very little JavaScript. Really, the first 15 years or so of the web featured applications with an enviously simple model for managing state. Load a page, click a thing, which loads another page, or you maybe submit a form, which loads another page. And the programming model for interacting with this state over time was also simple. Read a form value, read a cookie, update some database state, write a cookie, then write some HTML. And importantly, PHP apps were not treated as long-running stateful services. Each request started with a clean slate. And each URL route was actually associated with a different PHP file to be run, which means that state management was really, really simple. It was novel and a unique kind of runtime model at the time, and we haven't actually seen that many other examples of programming languages that use this runtime model until pretty recently when we see serverless and Lambda functions, which bring these back. So I like to think of PHP as serverless before serverless. So all of this really was like the OG one-way data flow for UIs. Of course, this means that every state transition is actually a full page load, and in 1999, that happened over a dial-up connection, which was painfully slow. And it also doesn't really allow for rich, client-side, event-driven apps like chat. And Facebook Chat, which is the predecessor of Facebook Messenger, was really the first client-side JavaScript-heavy experience on Facebook. It was built in 2008, followed the well-established MVC pattern. This was 2 years before Backbone.js, by the way. But for years, the same bug kept popping up over and over. We called it the zombie notification. Something on Facebook would light up as if you had a message, and excited, you go to click on it, only to find there's nothing there. Nothing, no new message for you. And this was actually the first project that Adam Wolf, my longtime manager, worked on when he first joined Facebook. He's actually now VP of Engineering at Robinhood. Come join us, we're fun. He wanted to better understand what exactly was causing this problem, but at the time, Chat had pretty much no automated tests, and it was pretty difficult to test anyway because it relied on subscribing to all these various event streams that came from all these different sources. So that led us to build this new JavaScript test framework with mocking as a first-class concept. We called it Jest. So we were actually using Jest at Facebook for 4 years before we open-sourced it. Glad we did. It's pretty good. So with tests in place to catch regressions, we now had a much better understanding of what the problem was. Events were resulting from updates in the chat UI that could come from server-pushed events, metadata from a page transition, or just browser events, people directly interacting with chat. And also chat appeared in at least 3 places. There was the messages view, the chat bar, and the notification icon in the top corner of the screen. So each of these different views had their own logic for handling events and keeping themselves up to date. So this was just impossible to keep track of in your head, and it led to just tons of inconsistencies just because of missing edge cases in the code. It's just way too easy to get wrong. So our solution was to rewrite chat with a new architecture. They wanted to take the mental model of simple server-side state, but implement it all in client-side JavaScript. So any event that could alter some state changed from an event emitter with listeners to instead be represented as an action. And an action was just a declarative description of what could change. So this declarative action is then dispatched to a store of data, much like you would send a post request to a simple stateful web server. So we called this architecture Flux. Of course, for simple web server style approach to be complete, the result of dispatching this action should be similar to what happens in response to a web request. The entire page should be replaced with the new response that includes the result of that change. And that would be very different from how we were building client-side UIs at the time. If you looked at the callback for these new message events, they would be directly constructing new DOM nodes with calling append child on chat window DOM elements. Basically, there's a reason why we avoided doing this kind of stuff in the first place. Changing this from replacing the entire view, it wouldn't necessarily be better. It could be slow, it could flicker the UI, it could lose things like your scroll position or whatever you happen to be typing at the moment, particularly important for chat. So these, of course, were the motivating reasons for building React. And so Flux and React together provided a much better abstraction for managing state, which allowed us to build the one-way data flow from the simple PHP apps of the 90s, but in the dynamic JavaScript clients of today. Of course, now few of us use Flux as it was presented 5 years ago. We've since then continued through this loop of better abstractions, clear APIs and syntax, and more refined mental models, which led us to Redux, using connect decorators on React components, thinking in terms of reducer functions for state. And React itself has continued through this loop, adopting class syntax, clarifying the mental model of component lifecycle, improving the abstraction with React Fiber, and further simplifying syntax with functional components and React hooks. So React functional components with hooks feel familiar to me. They feel like this simple PHP code from 1999 where you just wrote functions which declared your state and then rendered a complete view from templates. So I think LAMP became so popular in large part because PHP provided this really compelling mental model with expressive syntax for building web apps. And 20 years later, it feels like, in a way, we found ourselves back to where we started. And that's thanks to the steady march forward of better and more powerful abstractions, clear and more expressive syntax, and improved and refined mental models. And this has helped us build richer, faster, more complex experiences, grow our community to millions, and connect billions of people to the web. And now, I think with the benefit of hindsight, it's not all that surprising to me that Facebook has been responsible for pursuing a lot of these ideas. It was originally built by people who, like me, learned programming by building things for the web in 1999 with the LAMP stack. As Facebook grew in product complexity, popularity, and team size, it encountered all of these challenges, became frustrated with the existing solutions, and drew inspiration from the simplicity of the early web. And that led us to better view rendering with XHP, React, and JSX, better data fetching with preparable style batching, async functions in GraphQL, and better state management with Flux, Redux, and now React hooks. And I don't think we're anywhere close to done either. There's still plenty of problems to improve upon that could benefit from this same progression of better abstraction, syntax, and mental models. Hopefully, maybe, again, inspired by ideas from decades ago. All of which makes me wonder, what will the web look like in 10 or even 20 years from now? So we're all here because of a sequence of events that started with this very question. Does it even make sense to open source GraphQL? This is my quote. I'll admit, at the time, I was pretty skeptical. I didn't know if people were going to find GraphQL useful for their typical APIs, or if GraphQL was really only useful for complex things like newsfeed. And if other notable companies would use this, or if they would just go try to build their own thing. And even if they did, what would it even mean to open source this thing in the first place, since GraphQL really at Facebook was a bunch of PHP code interwoven with Facebook's core systems. So we wrote the specification and a matching reference implementation for Node.js, which we figured would get a little more attention than PHP. We announced it as an open source project in 2015, where we shared both the spec and the reference implementation, and we called on this community to help us write implementations in their language of choice. By the end of that year, many such projects were in the works, and today GraphQL implementations are available in over a dozen different programming languages, all managed by you guys, like different community members. That has allowed our community to grow worldwide. There's now GraphQL meetups across the globe, and major GraphQL conferences like this one in America, Europe, and Asia. So GraphQL has been an open source project for longer than it was internal to Facebook now. The last 4 years have shown that my early skepticism was unwarranted. This community contributing to and using GraphQL has become far, far bigger than just Facebook. And to reflect this, we've shifted our focus to developing GraphQL into the stable base, atop which many tools and businesses can thrive. So about 2 years ago, in an effort to move the center of gravity outside of Facebook, we started the GraphQL Working Group, or we call it the GraphQL WG. And this is a group that anyone can join, that we meet regularly, and our goal is to improve the language, the specification, and the ecosystem. So that group has since helped develop and improve subscriptions, the schema language, error handling, general documentation, and a lot more. And actually, a month after we started that, we doubled down in that direction by appropriately licensing the GraphQL spec under the Open Web Foundation Agreement, or the OWFA 1. So earlier this year, we continued. We continued to move the center of gravity into the community by announcing the formation of the GraphQL Foundation. So our mission at the GraphQL Foundation is to accelerate the development of the GraphQL ecosystem and enable widespread adoption. So we want to do that in a few important ways. First, the foundation is this neutral legal home for GraphQL and its most critical projects, developed by people across the community under a common code of conduct, and expands the set of maintainers for these important open source projects. A great example of this, by the way, is Graphical, which has just gotten a ton of new lifeblood in the last couple of months. Next, in collaboration with the Joint Development Foundation, we've actually created a formal standards body and a technical committee that's responsible for advancing the GraphQL specification and accelerating the future of open standards built around GraphQL. So our existing working group is actually the very heart of this effort and remains free to join and open to everybody. And then finally, the GraphQL Foundation creates the space for collaboration and coordination between the many companies who hope to see the GraphQL ecosystem thrive by bootstrapping and funding community initiatives. We already have 19 members of the governing board of the GraphQL Foundation, including Facebook, AWS, IBM, Intuit, Neo4j, Salsify, Apollo, Hasura, and a lot more. But we're just getting started. The goal isn't to land at 19. The goal is to collect every company who's contributing to the GraphQL ecosystem. So if your company uses GraphQL and you are interested in helping us pursue this mission, we need your help. We want your help. So learn more at foundation.graphql.org. Convince your companies to play along, and we'll help lift this community up even more. So once again, I want to thank you so much for being here and being part of our growing community. It's absolutely humbling to see our ecosystem develop, and I really can't wait to see what our community does next. In particular, I want to thank all the people who helped make this conference happen. In particular, Kate, Johanna, Itel, everyone at Honeypot and Prisma. I'm super grateful for all of their hard work for putting on such an amazing conference. So please, round of applause for all of them as well.